Okay, I'm doing a homework problem here where we have a boat traveling on the river, and there's three different scenarios. In scenario A, boat A, it's traveling at, well, it's angled 30 degrees north of going east, or above the horizontal, 30 degrees above the horizontal, and the motor is pushing it at 5 meters per second, and that with that vector drawn there. Here, this arrow is representing the current, and the current's going at 2.5 meters per second. So it's this blue guy. Okay, so what is it's asking for? What is the resultant speed? Well, I kind of drew some things out here to help us figure that out. We have 5 meters per second here, the green arrow. I'm just redrawing all the vectors together to represent the resultant. So we're going 5 this way, then we're going to go down 2.5. I can sketch in there the horizontal. Oh, this is bad. This is bad. Oh well, we're going with it. Okay, so this would make a 90. This right here is at 30 degrees. So I'm just redrawing over here, this stuff over here to right here to get our result. Okay, let me take that stuff away. So if we add up these vectors, how you do that is you go from the bottom of the first vector, this green guy, and you go to the end of the last guy. So that would be right here. That's the resultant. So the triangle is made up of this green, that blue, and this red resultant. Now, there is no 90-degree angle in here. We do not know the angles. We can find them, but we don't know them. So we have a triangle right now with one side 5, another side 2.5, and we don't know the last side. Okay. Alright, so let's think about what's happening here. The river's pushing down at 2.5. The motorboat is going at this angle here at 5 meters per second, but this 5 meters per second has an x component, a horizontal component, and a y component. All right, we can't add 5 to 2.5, obviously. No, we have to find the triangle sides. But we can add this y component of the 5 meters per second to this 2.5. It's going in the opposite direction, so they're going to subtract, but we're going to add, subtract this y here and this 2.5. We can do that. So if we know the result of that, this y total, so if we can find y total, and we know x is the x direction, or the x speed, or the x component of this 5 meters per second, is the only thing that would be contributing in the x for the r, the resultant down here. So we need to find this side and this side of our r. And if we find that these two sides, we can use a squared plus b squared to get us this hypotenuse r, because this y total and this x total make a 90. So if we know them, we're good to go. This r right there, that 90 needs to go away. Okay. So so if we can get this y total here, and this x total here, we can find the two sides of our r, right triangle, and we can find the result. Okay, so how I did that was I said, okay, I'm going to break down this 5 into its y and x components. So I redrew it down here. With the horizontal, this 5 meters per second makes a 30-degree angle. Okay, so we know an angle, we know the hypotenuse because we're looking for all y, all x, so this is a 90 right here. So I can use my trig identities. Sine theta equals my opposite side, which is y, over 5. The cosine theta equals my adjacent side over 5, the hypotenuse. I have equations now solving for my y and x. I just solve for y and x in both of these equations, and for my y, I got y to be 2.5 meters per second. That's a positive, so that's going up. So up. And in the x, I got a 4.3 meters per second. So that's just across. That's all. In this case, the positive is to the right. If I look at my drawing, we're saying this way is positive, so that's to the right. You might be like, okay, so what are we doing with this again? All right, so these are the sides of my red triangle here, my red and black triangle. Well, they will contribute to the sides. So I have to total up everything that's happening in the y direction and everything that's happening in the x direction. These are my totals here and here. Okay. So my y, everything that's happening in the y. My motorboat's pushing up 2.5 in the y. And the current is pushing down on the boat 2.5. So that's a negative. If I'm saying up is positive, then down has to be negative. So in the y direction, we're going 0 meters per second. Okay. In the x, our movement is coming from the motorboat, and the x component of the motorboat, and we found that here. And we found that to be 4.3 meters per second. Well, so my resultant turns out to be having no y. So there is no y component of my r. It's all in the x. That's what this is telling me. I'm going in neither up nor down in the x, and I'm going, or in the y. I'm not going up or down in the y. The river cancels out the motorboats, push up. So the resultant is the x. It's all in the x. So the resultant equals that. I mean, you could draw a triangle with these two sides. Here's my x component, xt is 4.3. And I have 0 y, so I'm not going to draw a y arrow. And there we go. It's not really a triangle, it's just a line. So that is the resultant.